problems number 2, 3, 4, and 5. There's a triangle, kind of like this, drawn in your page for you. It asks you to find lengths of indicated segments. In other words, there's a missing length that you don't know. But they have given you lengths of other segments. So looking at number 2, it says AD is 10, DB is 5, AE is 8, and what do we not know is this here, this EC. This is the unknown. We are told that DE is parallel to BC. With that knowledge, we know that these triangles are similar and the sides are proportionate. That's one of your theorems that we know. Given that, that would mean I need to set up a proportion to solve for the missing side. How would you set up the proportion? Would you put 10 over 5 equals 8 over, let's call it just EC, because that's the section. That would work, right? 10 over 5, 8 over unknown is proportionate, correct? Any confusion about that? Would you do it differently? This is number 2. On page 25. If we were to work this out, I would have 40 equals 10 times x, or EC, my unknown. Divide by 10 and I find out that EC is 4. That seems right, correct? Because if this is 10, that's 5, 8, and 4. That seems proportionate. So that is correct for number 2. Number 3, my numbers change. And I'm given AE is 21, EC is 7, DB is 11, and what I don't know is AD now. So using the same proportion, I can set this up as AD over 11 equals 21 over 7. That's supposed to be a 1. Now what's 21 times 11? You know the 11's trick? 21 times 11 is 231. And then of course 7 times AD. And what is this? 7 going to 231?
3.
33?
20. Wait, no, 33, yes.
33 times. 3 times 7 is 21 with 21 left over. All right, yeah, so 33. Now 4 and 5, on problem number 4 there, because this was problem number 3 that we just did. Problem number 4, there's a hint. The hint says find DB first. So 4 and 5 are just like we've done, only the question it's asking you to find is the whole length. So just like in this one, I found that AD is equal to 33. So if I wanted to know AB, I would add these two together. 11 plus 33 gives me 44. And I would know what AB is in this situation. You're doing that same thing to solve for 4 and 5. Page 25, number 6. This is a proof. With a drawing that looks like this. Your given is triangle XYZ, and angle 1 and angle 2 are congruent. So you can go ahead and mark those as congruent. Those are given. I'm supposed to prove this proportion. XA over AY equals XB over BZ. In order to prove that proportion, I would need to know what? What would I need to know? How would I solve that? My first step is given. That's the given information that we just read. Our step 3 we're trying to prove is that XA over AY equals XB over BZ. Here. Step 2 and reason number 2 and reason number 3 are all unknown to us. If I look at this and I see this angle is congruent to that angle, these lines both intersect the same line. That looks like something that I remember when I dealt with remember transversal? If they're on the same side, these would be called what when it comes to the transversal? So they're not alternate, they are what was the other one that we used? Remember corresponding angles? So if a transversal intersects two lines, like this transversal is doing, such that the corresponding angles are congruent, which is what we were given, then the lines are parallel. So I can say that AB is parallel to YZ. Those segments are parallel, AB and YZ. You follow that? I didn't write it here, but what you would write for your reason is that if transversal intersects two lines such that the corresponding angles are congruent, then the lines are parallel. Remember that theorem? That's way back when we dealt with all those transversals. So that's what you would write here. For reason number 3, what would I say? Because I now have what I was given, that these two angles are congruent. I now know these two are parallel. Is there a theorem that has to do with parallel lines with triangles? And what is it? Remember the one that says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the two sides proportionally. So it's parallel, intersects, and they're divided proportionally. That's your theorem. That's what you would write for reason number 3. Page 27. For how to complete one of these constructions on page 27, look at the example on page 26 and follow that through. Page 27, let's look at number 2.
This is for hot chocolate.
Number 2,
Floor hot chocolate.
line A is rather lengthy.
Huh?
B is shorter.
Oh.
And C is even shorter than that. Does that kind of resemble the segments on problem number 2 on page 27? Let's just say it does. First thing I need to do is create my angle I'm going to use to create my proportion. My angle I'm not sure that this is going to be long enough. Maybe it will. Let's see. Now wait a minute. It says to construct a segment with a length x for each problem such as that AB equals C over x. Very important to know this. AB equals C over x. That's how I know where to draw what. A and B equals C over x. That makes sense? If these were moved around, I would need to draw them in a different order. You'll see that on problem number 3. They gave you x over A equals B over C, so you have to move that proportion around. In order to draw that appropriately, you really need to have the unknown in that 4th position. right here, that's the fourth spot. You don't need to have it there. It's not given that way to you on number 3. In order to solve it, you need to move it there. Let's see how we do. Let's see. What do I need? Oh, here's my compass.
Where's the straight edge that was in here?
I need to recreate A
Aha.
over B on this side, correct? So let's do that. A.
Bring a pack of chips.
Here's A.
Dang, I done sold it.
Uh-oh, we can move that afterwards. Keep your compass nice and tight so it doesn't change lengths on you. And let's see if I can create B now. There's B. So this section here was A, that A, and this is B. This A over B is C over X. So I need to create C down here. Using your compass, put it here on one end. Make it that length. There we go. This length here is C. I need my straight edge again. And I need to create my line that goes through these 2 points. There we go. So I'm going to then, using the example again on page 26 as a reference, I need to create a second line parallel to this line that passes through here and then some unknown point here. I don't know where it is because that's what I'm trying to solve for. That's my unknown X, this unknown length here. I don't know what it is. So how do I find it? I put my pointy end here and get this distance. Whoops, I didn't go far enough. Let's try that again. I need to intersect both sides. Okay. I need a reference point to start from. All right, what I've got so far hopefully makes sense. I've got this line, and I put my compass so I was able to create this arc that passes through this point but touches this side. Because if I want to be able to recreate a line that goes through here and that's eventually going to intersect to this side, I need to know what this distance is so I can recreate it there. And of course I'll do that using my compass again. This will be much easier on your paper with your little compass. Let's see if I can do it here. That distance is equal to that distance. Let's see if this one came out better. Now I have my 2 points. I'm connecting here with here. That is the same arc distance as there. Let's see if that looks good. That's pretty close. Not very dark. I hope you can see that. This is a little extra, as this would be. So there's A, B, C, and this, we now know x. That distance there is the x. So that was how we create an unknown segment using this proportion. And we got to use our compass and straight edge and draw that out. That one makes sense. This one I think worked out well. So that was problem number 2 on page 27. Problem number 3 on page 27. Let's get that set up correctly so we know what we're solving for. And then you'll do it the exact same steps, exact same way. For problem 3, the proportion they're giving you is x over a equals b over c. You see that there in the middle of the page? However, it says, remember, rewrite the proportion so that x is in the fourth term, this spot. So I know proportionately I can switch these two and it's still the same. Right? C over a equals b over x. That's the proportion I want to use. Meaning when I go to draw my sections, C over A, see here we had A over B, so I put A first and then B. When you go to draw this one, where will you put C? Not down here, but up here, right? So you'll draw your C length over the A length, then the B length, and then your unknown will still be this fourth section as the unknown, x. So get your proportion set up right, that way you know where to draw your segments to create your proportion. And it will come out just fine. Page 28. That's our checkup. Numbers 1 through 4 on the checkup ask you to match that drawing with your postulate or theorem. So the first drawing is this. All right, that's not perfect, but hey, close. Now probably I should put the mark on that side, but you get the idea, I hope. That this is a right triangle and that is a right triangle. So if you have two right triangles and you're trying to prove them similar, which postulate or theorem do you suppose you would use? Look at A, B, C, and D for your options. And you're going to pick what?
A, B.
I would go with C. Right triangle, similarity, corollary.
Oh, we didn't see that one.
Seeing as how that's a right triangle we're trying to prove. Number 2. Number 2 is the geometry bow tie.
Bougie.
It's kind of an angledy one. Maybe like that, I don't know. You're given that angle and that angle are congruent. Which postulate or theorem would you use to prove those as similar triangles? You've already eliminated right triangle, so you have A, B, and D to pick from.
D.
I would go with B, because you're already given these angles, and you would know that these are congruent as well, because of vertical angles. So number 2 there, 2 is B. This was number 1. Where we put C. Oh, look at number 3. That one's a fun looking one. It's hard to spot the triangles.
Bird.
It's got this going on.
Look at this, like the eye.
Then it's got this.
See a bird. Doesn't it?
You see a bird in that?
Yes. Y'all have no imagination. Creativity is.
I mean, not
See
even
it
Dr.
in the
Seuss
hallway.
would see a bird in this.
There is a bird.
Oh, well, I'm glad you see it. What this is trying to tell you is what? If that is a right angle and that's a right angle, then we know that these lines are parallel. Now, which of these 2 remaining choices do you suppose you would use to prove triangles similar?
A.
Man, I wanted to say congruent. Remember proving triangles congruent over and over again? That will be very loud on the recording.
Oh, really?
Yes.
Cool.
Your tapping thing or whatever you were doing in the last one was really loud. I had to cut that whole segment out.
Oh, fun. I think I was tapping in the last one.
Your tapping caused it.
Now there's going to be a bell ringing in the background.
Time to go to church.
All right, number 3, we have this shape, and we see that choice D says if a line is parallel to one side of a triangle and intersects the other two sides, so parallel to that side because of this, and it intersects these two sides, we can see, then this makes them similar triangles. Now, number 4. I know by process of elimination we know what we would choose, but let's say we had a whole list of things and we didn't know what we were going to pick. Given the markings, you see you have 2 angles that are given to you as congruent inside this triangle. There is a third shared angle. Remember, we're always looking for that third shared angle. So that means I have angle, 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 right? For this one. I put all 3 A's in the blank, but it's really just choice A. Angle, 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 similarity postulate. You're going to be given a number of these type of examples in the future, a number of them. And you're going to need to be able to state which of these theorems or postulates you would use to say, hey, those 2 triangles are similar. Are we paying attention to that?
I got it to balance.
That was a great, hey, this is going to be on the test moment. So I hope you didn't miss it.
I didn't.
Proof number 7 at the bottom of the page is a very short 3-step proof. We're given the same type of triangles we've seen over and over again. We have a triangle within a triangle, and you're given that 2 angles are congruent. See that? So hopefully you will be able to come up with a quick way to prove that those triangles are indeed similar. And that finishes up page 28 part of the checkup, but the checkup continues on page 29. See that? Turn the page. We have a whole lot more that the checkup continues to do. Proof number 8, you have 2 triangles up there you need to work through. Problems number 9 and 10, you're finding unknown lengths. So that again is where you will use proportions to find the unknown length. There you'll find the number. I know we're skipping a few, but if you look down on 14, 14 asks you to construct a segment with a length x that completes the proportion that they're giving you. So you do the same in page 29, number 14, as we did together on page 27. Now back up to 11, 12, 13. You're completing the proportions, continuing based on what that you've been given. So that is the last part of the checkup.